Hi students, welcome back to my lesson video. So in this lesson we are going to talk about group 1 elements and yeah, as the name suggests, it's the first group of elements in our periodic table. So let's look at this group of special elements. So first and foremost, they have a specific name. So these are all called alkali metals. So that means we are referring to lithium, sodium, potassium, rubidium, cesium, as well as francium. Okay, so the first vertical column that we see, all these elements, they are called alkali metals. So you might be wondering why it's called alkali metals, right? So there's a particular reason behind it, and once you learn acids and bases, it should be a lot more intuitive and you will understand a bit better. So basically the reason behind is that group 1 elements, the group 1 metals, they will react with water to form what we call a hydroxide solution, and a hydroxide solution is alkaline. Okay, so the OH minus hydroxide ion actually makes the solution alkaline. So once we go to the chapter on acids and bases, we will talk about it a bit more extensively. Yeah. Okay. So for now, let's continue to talk about physical properties of alkaline metals. Okay. So there are 3 that you need to know. The first one will be that the alkaline metals, they are very soft and therefore can be cut very easily. Okay, so let's watch some videos to demonstrate to you what this means. So if we have a look at this video, right, over here you will see certain metals, okay, that comes in a little block, and you will see some scientists over here using a scalpel trying to cut into the metal. Okay, so even before I play the video here, you can already see that it's quite easy to cut into it. Okay, so let's play the video, have a look. Okay, it's really quite easy to cut it because it's very soft. You realize that the metal is grayish in color, but once you freshly cut the metal, in this case, you will realize that it forms a silvery layer. Okay, so yeah, so once you freshly cut into it, it's still silver, but then if you leave it to stand for a while, you'll notice that it start to become gray again because oxidation would have taken place, meaning the metal, because group 1 metals are very reactive, so it will react with oxygen in the air. Yeah. Okay, so you'll learn about that a bit more in redox. So over here you notice there are certain metals which are further down group 1, right, such as cesium or even francium. They are stored in this kind of container. Okay, not container, kind of a vial, a glass vial, because as you go down the group, your group 1 metals become more and more reactive. Okay, so yeah, which we will talk about very shortly, but in this video I just want you to appreciate that group 1 metals, they are really soft and can be cut easily. Okay, so that is the first physical property. Moving on to the second physical property of alkali metals. Okay, so if you look over here with me at the left hand side, right? Okay, second point is that in terms of melting and boiling points, the alkali metals have very low melting and boiling points. Okay, so I'm just going to give you a very quick explanation for you to appreciate why this is so. So, okay, let's go back to our good friend sodium, which is 2.8.1. We should be super familiar with this by now. So, looking at the electronic structure or dot and cross diagram, this is how it is, right? So, 2.8.1, 2 electrons in the innermost shell, 8 electrons fully filled for the second shell, and then a third shell which has 1 electron. Okay, and this electron is also known as the valence electron, right? Because it's the outermost. Okay, yeah, so this electron is the valence electron, and again, because there's only one valence electron, so sodium is placed in group 1, okay, because group number tells us number of valence electrons. So if you think about it, let's go back to our concept from atomic structure, right? So in the center here, which is where your nucleus of the atom is at, the nucleus basically is made up of protons and neutrons. So protons, they are positively charged, neutrons, they are neutral. So if you think about it, right, your nucleus is like a very dense center in an atom, and then your electrons are all surrounding it, right? And then it has a certain form of electrostatic attraction. Okay, so if you look over here, so let's say if you have an electron that is in a more inner shell, okay, it will have a very strong attraction, versus if you have an electron that is very far away, the attraction is a bit less because it's very far away. Okay, so meaning position A versus position B. So yeah, okay, so okay, back to explaining why it has group 1 metals have low melting and boiling points, right? Without going into too much detail, which you are not required to know now, just appreciate the fact that as you go down the group, you have more and more electron shells, your valence electron becomes further and further away. So therefore, in a chemical reaction, the valence electron is being lost more easily, right? Because it's not as tightly held on by your nucleus anymore. Okay, so therefore it results in a low melting and boiling point. Okay, so keep this in mind. Later on, we will also talk about trends in group 1, and we will talk about this. You will see this again. Let's now look at the third physical property of alkali metals. And now we're going to talk about the densities of alkali metals. Okay, so in general, for density, alkali metals all have low densities. Okay, so again, we're going to watch a video to have a look at why this is so. Alright, so over here you can see there are samples of lithium, sodium, as well as potassium metal. So over here, this guy, he just placed a piece of lithium metal into water, right, in the beaker, and you notice that the lithium metal is just floating around on the surface of the water. Okay, of course there's a chemical reaction happening because you see there's vigorous bubbling, right, shows that it's vigorous reaction, and then you can see that he's trying to put his finger to touch the beaker, right? Yeah, so if you were to do this experiment in the chemistry lab on your own, you will realize that the beaker now is very hot to touch. Okay, so we call this exothermic reaction because it releases a lot of heat. Okay, so we will learn that in Sec 4, so we can look forward to that. So now let's look at sodium, right? Sodium is one element below lithium in group 1. Okay, notice that now the reaction is a lot faster compared to that of lithium. Okay, then now when he touches the beaker, he cannot put his fingers there for long because sodium now is more reactive than lithium. It also generates more heat in the reaction. Okay, then finally, now you look at potassium, even further down the group. Okay, so you'll start to see the trend coming out already, right? So if sodium is going to be more vigorous, right, the reaction, likewise for potassium, have a look at it. Immediately the reaction starts, right? There's no lag time at all, and in fact now you can see a flame. Okay, yeah. Okay, so I've gotten ahead of myself. Basically, in this video, what I wanted to demonstrate to you is that the metals, the alkali metals, they have low density because you realize in each of the reaction that you have seen here, the metal floats, right, on top of the water. Yeah, so since it floats on water, it is less dense. Okay, so they have very low densities. Yeah, that's my point. Let's carry on now to talk about the change in properties down the group. So we are talking about periodic trends here. So as I mentioned before, periodic table, right? So from the word periodic, it already suggests that there's some sequence, some trends going on. So let's look at the change in physical properties down the group. Okay, so mainly melting and boiling points as well as densities. So for melting and boiling points, the alkali metals down the group, it will decrease. Okay, so as I've mentioned just now, the valence electrons, right, is further and further away. So in a sense, it's less tightly held by your positively charged nucleus in the atom. So therefore, the melting and boiling point gets lower and lower. Whereas for densities, that will generally increase, because if you think about it, as you go down the group, you have more and more electron shells, and you have more and more of your subatomic particles as well, right? Your protons as well as neutrons, which are the ones that have a bit more significant mass. Okay, and remember, density is mass over volume, right? So if you increase mass, definitely your density will increase. Okay, so that is not difficult to understand. Yeah. Okay, so then moving on to chemical properties of alkali metals, we have had quite a bit of a glimpse just now, right? Your alkali metals, they are highly reactive. Notice that just now in the video, you were basically just putting the metals into water, correct? And then they are reacting so vigorously already. Okay, so the fact is that for alkali metals, let's say if I don't know, maybe next time you go to university and you have access to the more advanced labs, right? And then you will notice that all these alkali metals, they are usually stored in oil. Okay, so if you look with me at where my cursor is, at this photo on the left, right, this picture, basically this is lithium metal, right? This definitely is a metal, right, because it's shiny and it's low density. Okay, this is the alkali metal. So this is actually lithium stored in paraffin, okay, which is a kind of oil lah. Okay, so the reason is because is to prevent them from reacting with air and water, right? So they are highly reactive, and then like I mentioned, it will tend to want to oxidize, correct? So again, when we get to the redox chapter in Sec 4, you'll learn that for oxidation to take place, there are several things that you need, of which you need oxygen. Okay, so in Singapore, where it is very humid, and obviously oxygen is in the air, so in Singapore actually it's very hard to store this kind of metals. Okay, because they will readily react. Yeah. Okay, let's have a look at the trends in terms of chemical properties of our alkali metals. So as we go down group 1, you notice that the size of the atom starts to increase. Okay, so we can have a look at, let's say in the notes I drew you this potassium atom, right? So we are very familiar with sodium so far, right? 2.8.1 is like a magic number that you remember by now. So sodium 2.8.1. So potassium, knowing that it is just one element below sodium, okay, it has a period number of 4 instead of 3, right? So it has 4 electron shells. So the extra electron shell basically is what attributes to why the atom increases in size. Okay, so this one not difficult to understand. So therefore, it is easier to lose the valence electron from the bigger atoms, right? So potassium, it's easier for potassium to lose that valence electron compared to sodium. Thus, your reactivity increases down group 1, so that's your trend. Okay, so you can fill in the blanks over here. The order of reactivity is lithium is less reactive than sodium, which is then less reactive than potassium, and so on and so forth. Alright. Okay, so continuing our discussion on chemical properties, so talking about how alkali metals react, right? There are a few types of reactions that you need to know. So the first type is that the alkali metals react with cold water to form an alkali and hydrogen. So basically this is what we saw in the video earlier on, right? Yeah, so just now there was a beaker of water, right? So tap water basically just normal cold water. okay, then your metal will immediately react with it because alkali metals are so reactive, right? And then it forms an alkali and hydrogen gas. Okay, so okay, so this part, right, in terms of observations, the keywords are very important. So for instance, for lithium, the observation is that it reacts quickly. Okay, and then there's the equation of reaction, which you need to know. So word equation as well as chemical reaction, chemical equation. Okay, so in terms of chemical equation, quite a lot of things to take note of. So state symbols must be correct. Chemical formula, of course, needs to be correct. And then you need to balance it as well. So for this part, we will practice a bit more when we meet face-to-face in class. Sodium, on the other hand, will react violently. Okay, so visually you also observe that the sodium will dart around the water surface, and it might be potentially explosive. Potassium, okay, it reacts very violently. That one we saw, right? In fact, there was a flame. It was a very vigorous reaction. Okay, so yeah, alkali metals. So basically you need to remember lah. It will react with cold water. You don't even need to supply any heat to it, right? Remember, certain reactions, you need to give it heat energy, right, to kickstart the reaction, to have the energy to even start to react. Okay, such as for instance, you supply heat via a Bunsen burner, but then for alkali metals, because it's so reactive, right, it can even react with cold water. Okay, and it always forms alkali and hydrogen gas. So this particular type of reaction, we will see it again when we go through the topic on metals. So you'll start to see again more concepts coming together very nicely. Okay, so that's akan datang, coming pretty soon. Moving on to the second type of reactions that alkali metals go through. Okay, you need to know that it is an oxidation type of reaction. Okay, so all alkali metals, they will form ions with a charge of +1 by losing one electron from the valence shell. Okay, so this one, so far you already know from atomic structure, right? So again, back to our good friend sodium, which is 2.8.1. Okay, remember all elements want to be like the noble gases, right? Because the noble gases are inert, they are unreactive, they are very stable. So they're happy being in their atomic states. So sodium, for instance, in order to achieve that stable octet electronic configuration, it will lose this one valence electron to form sodium cation Na+, which has an electronic configuration of 2.8. Okay, so now it's very stable. Yeah, so this is what you know so far. Okay, so we can say that alkali metals, they are powerful reducing agents. So this part you will understand more fully, I would say, when we come to Sec 4 and we learn redox. Okay, but for now, just know that oxidation, this is an oxidation reaction because electrons are being lost. Okay, so yeah, for now, just know that. Okay, then the third type of reaction, or rather the third chemical property, okay, that alkali metals have, will be that alkali metals form ionic compounds. Okay, yeah. Remember, ionic compounds, right, is basically made up of the metal component as well as the non-metal component. So for instance, in this case, or rather if we look at simple examples, let's say lithium fluoride, lithium chloride, and so on and so forth. Okay, so their compounds will always have similar chemical formula, and they are also soluble in water. Okay, so this you need to go back to the chapter on ionic bonding to revise a bit. Okay, so just to give you some examples, so for instance, let's say I use this polyatomic anion, right, carbonate. You'll notice that the chemical formula is very similar, right? This is lithium carbonate, sodium carbonate, and potassium carbonate. Okay, so also take this opportunity to remind you of the polyatomic anions that you need to memorize. Okay, so carbonate is CO3 2-, sulfate is SO4 2-, nitrate is NO3-, and then hydroxide is OH-. Okay, hydroxide ion is also the one that gives you the alkaline properties. Okay, so yeah, for this video, this lesson, we will stop here. We will proceed to do our worksheets and practices separately. The next video will be, as you can see here, it will be on group 7 elements. So it will be good if you can read up beforehand so that we can have a head start before the next lesson. Okay, thanks, bye.